Okay, this video is going over some more operations with radicals. So the first example, we're multiplying two monomials. So when you don't see any addition or subtraction, you can simply multiply the whole numbers together and multiply the radicals together. So 4 times 2 will give you 8. Since 10 and 8 are both underneath the radicals, we can simply multiply them. That's going to be times the square root of 80. Don't forget to check that the number underneath the square root needs to be simplified as much as possible. So if you do it the fast way, you can recognize that 16 is a perfect square that goes into 80. So 16 times 5 is 80. I can break that down into 16 times 5 because the square root of 16 is a whole number, 4. So we simplify the square root of 80 to 4 times the square root of 5. Don't forget to drop down your original number, 8, and remember this means that we're multiplying it. 8 times 4 root 5, which would be 32 times the square root of 5. Remember, if you do simplify the square root of 80 differently, you can always do a full factor tree if that's the way that makes most sense to you. If you do it that way, remember you're going to get 2 times 2 times 2 times 2 times 5. And remember, you can just pull out pairs of 2's. You'll get the same thing, 4 root 5 either way, and just multiply that by 8. All right, second problem. We have one term multiplied by 2 terms, so we're going to have to distribute the 5 root 3, multiply that by both terms. So remember, root 3 times root 6, since they're both under radicals, they get multiplied. 5 square root 18. Then we multiply 5 root 3 times 3. 3 is a whole number, so it gets multiplied by the 5. 15 root 3. And again, double check that all of your radicals are in simplified form. 15 root 3 we can't do anything else with, but 18, notice, if you do a factor tree, can be 3 times 3 times 2, or root 9 times root 2, which simplifies to 3 times the square root of 2. Drop down the 5, which is multiplied by that. So that first term is 15 times the square root of 2, and it's being added to 15 times the square root of 3. Remember, we saw yesterday's lesson, these are not like terms. You can only add radicals if they have the same number under the radical, and they're not like radicals, so that's as far as we can go with that problem. Okay? The next type of problem you may see is two binomials being multiplied by one another. So these are essentially the same type of problem, but this one is disguised because remember what this actually means is the 2 plus square root 3 being multiplied by itself. So you have to set up the box problem. You can't just square each one. So that's the big mistake we see on the test. Students will do this and say, oh, that's just 2 plus 3 and I'm going to get 5. So don't fall for distributing. You actually have to multiply this out and you're going to get a different answer. Okay, so root 2 times root 2 is going to be root 4, which is actually 2. Okay. Root 2 times root 3, square root 6. Square root 3 times square root 2, square root 6. And square root 3 times square root 3 is a square root 9, which again goes to a whole number, which is 3. So that means we're going to get 2 plus square root 6 plus square root 6 plus 3. Combine your like terms. 2 plus 3 is 5. Root 6 plus root 6 is 2 root 6. Remember, this is as far as you can go. 5 and 2 root 6 are not like terms, so just leave that alone there. All right, number 4 is just another box problem, or FOIL if you've multiplied out that way. Set it up like this and just multiply each of the dimensions. So 4 times 2 is 8. 2 times negative 5 root 5, negative 10 root 5. 4 times negative root 5 is negative 4 root 5. Be careful on this last one. So this last box is going to be negative 5 times the square root of 25. Square root of 25 goes to a whole number. So it's negative 5 times 5, so this whole box is going to be negative 25. Don't be afraid to write that out because that's where we see the errors. And just take your time, and sometimes doing it inside in your head without showing the steps can produce some errors. So take your time on those. Now I like to write it all out. 8 minus 10 root 5 minus 4 root 5 minus 25. Combine your like terms. 25 minus 8, that's going to give us negative 17 minus 14 root 5. So you're combining the integers and you're combining the radicals. All right. So those are some examples. We have some problems for you to do for practice. And I would pause the video. We'll put the answers up in just a minute. Here are the answers for 1 through 8. Go ahead and check those. If you missed any, I would go back and watch the video or look over your work.